This is one of the mock test paper of our batch, JEE Main 2026. If you could solve this paper in half an hour, then you can easily solve your JEE paper in your examination. Let's get started with the first question. Consider the following species BF3, BF4 minus, NH3, NH4 plus. The correct statement regarding the bond angles. I already told you how to find the structure or hybridization geometry of the molecules given. So find that way. If you could find that, then BF3 which will be 120 degree angle. Why is it so? Because that is sp2 hybridized trigonal planar. BF4 minus, that is sp3 hybridized 109.5 tetrahedral. Ammonia, we very well know about it. That is pyramidal shape with the lone pair on top of it, which makes the angle 107, and ammonium ion, which is very similar to tetrahedral, 109.5. So among this, what is matching? BF3, that is having more, then comes BF4 minus and ammonium, then ammonia. So option D is your right answer. Next question, it's a bit lengthy, but it's a very simple question, isn't it? If you watched our video of top 50 questions, you would solve it in seconds. Benzene with Friedel-Crafts. So A is toluene, correct? Friedel-Crafts alkylation. Toluene with K104 alkaline medium, which will give you COO minus. With hydrolysis, it will produce C6H5 COOH, that's C. C with SOCl2, that will give you C6H5 COCl, correct? That is D. What we'll do with ammonia benzoyl chloride, which will produce C6H5 CONH2. What is this reaction? We've told so many times, right? If you know this reaction, let me know in the comment section. I will send you the PDF of this mock test. What is F? Which will give you the F as aniline. Very simple question. How many stereoisomers are possible for the compound CH3, CH double bond CH, CHBr? It's like this. CHBr, then CHCl, CH3. So what are all the chiral center over here? This is in chiral center. And what about this? This is also in chiral center. They are asking all stereoisomers, not only for optical isomer. So we have to count double bond also. So the chiral centers are 2, and the double bond I have C2 and C3 system, which means 2 geometrical isomer E and Z can possible over here. And for this one, for the chiral centers, 2 chiral centers. So the total stereoisomers, we already shared a formula sheet of isomers. Please do check out in the shorts. We already shared it to how to find the isomers part. The 2 of stereoisomers plus 2 to the power 2, 2 to the power n. Here I have 2. So 4 into 2, 8 stereoisomers. That is possible for this structure. For E configuration, one set will happen, and for Z configuration, another set will happen. Then, Haber's process is given. Delta H value is minus 92 kilojoule. If the reaction is carried out at constant volume instead of constant pressure, the change in enthalpy would be. So we know the relationship, right? Delta H, that's equal to delta U plus P delta V or PV. So PV is equal to nRT. So delta nRT for the ideal gases. Here N value is product side 2 and the reactant side is 4. So a delta NG value, that is 2 over here, minus 2. So substitute the delta N value. Delta H is given as minus 92, delta U plus minus 2 RT So from here what we can observe is delta H is a state function. It does not depend on the path which is that taking. It's only depend on the initial and the final states. So whether carried out at a constant volume or constant pressure, if the initial and final temperatures are same, then delta H remains same. Right? Why I explained this formula? Because if they ask you to find out the delta U value also, you can find out using this type of question. But the answer to this question is equal to minus 92. Consider the reaction benzaldehyde with acetone, NaOH and heat to give the product. Which intermediate is more stabilized during the aldol condensation? They are asking about, they have given that is aldol condensation, but they are asking which intermediate is more stable. So here this is a cross aldol, right? Because I have one compound that is without alpha hydrogen and another compound that is having alpha hydrogen in it. So stabilization of an enolite where that will form? From acetone only. So it will form an enolite like this. So which is stabilized by the resonance of the carbonyl group, and through that the negative charge is delocalized. So that enolite will attack the system. So don't worry about the product what have been formed. They're just asking about the enolite. If you know aldol condensation, you can easily do this question. Answer to this question is C. The following electrochemical cell is set up. Platinum and hydrogen electrodes are used to form copper 2 plus 2. Copper 2 plus concentration is given. And E naught value is also given, and the measured cell potential is 0.456 volt at 298 Kelvin. The pH of the solution in the anode compartment is. So anode compartment where the oxidation happens. In this cell where the oxidation can happen? For hydrogen. Correct? So let's see one by one. E cell is equal to E cathode minus E anode. Right. So let's find out for copper. For copper, E naught minus 0.591 divided by 2 log of 1 by copper. Substitute the values over here. You will get copper 2 plus concentration is 0.1, right? So E of copper 0.34 minus, upon substituting log 1 by 0.1, that is equal to 1. Log 1 by 0.1, that is equal to 1 because log 10. So which is 591 divided by 2 into 1, that will be 0.31 volts. Now anode part. For hydrogen electrode, E naught is 0, right? So EH, that is minus this value becomes 0, right? Remaining 0.059 into H plus concentration, that is pH, correct? So I want pH value here. Just take both of the conclusions we have. So E naught cell value, E cell value is given as 0.456 is equal to what we have found for cathode, that is 0.31 minus for anode minus 0.059 pH. So from here, can you derive the pH value? So pH will comes to be 2.5 around. Let's check with the options. So 2 is the nearest one, so 2 is your answer. Reaction 2A plus B gives product. The rate law is R equal to Ka into B. The reaction carried out in the container, initial concentrations were 0.1 and 0.2 for B. When half of an A is consumed, we are adding A to make it as a 0.1. Okay, after consumption. Then now we have to find the rate of the reaction at instant compared to the initial rate. Okay, so now K R is equal to K A into B. So the initial rate, which is equal to K 0.1 into 0.2, correct? So which is 0.02 K. When half of the A is consumed, 0.1 becomes 0.05. So now as a second part, that becomes R is equal to, let me take it as an R1. What about B? If half of the A is consumed, what about B? Which is in 2:1 ratio. Right? So which means B is consumed as 0.025 part of B is consumed. So from 0.2 minus half of A, that amount 25, so which will give you 0.175. So now the R value becomes 0.05, 0.175. Okay, now what I have did, we have added A to restore its concentration. Now R2, let's say, now the concentration of A becomes 0.1, but B is still 0.175, so which will be 0.0175 K. Now we have to divide these two. They are asking to the initial rate, right? So this is 0.02, this is 0.0175, which will comes out to be 7/8, approximately 3/4 of the initial rate. Among the following complexes, the one that can exhibit geometrical isomerism but not optical isomerism. Here you see this is AA2 type, and this is A2B2, this is AA3, this is A3B3. So among this is octahedral, this is square planar, this is also octahedral, and last part A3B3, that is also octahedral. So easily you can find out the square planar one will not show optical isomerism, right? So which means B is your answer. That can only show the geometrical but not optical. Cis and trans isomers it will show. An octahedral ion complex have 5 aqua ligands and 1 nitrosyl ligand. Okay. The experimental measurements show that the complex exhibit paramagnetism corresponding to 1 unpaired electrons. Which of the following statement is most consistent with these observations? Ion which is in +2 oxidation state and the complex is high spin. So which is a very simple question. If you could see ion within 5 aqua ligands. So it must be ion H2O5 NO. Correct. So where I'll have the oxidation state of ion must be +3, because this is nitrosyl, plus oxidation state, and also they are saying paramagnetism behavior. So that must be a lone pair of 1 electron, obviously D5 state. D5 means what? That is +3 oxidation state. So low spin or high spin, one nitrosyl ligand, that is a strong field ligand. So which will undergo para? But still that is having a 1 unpaired electron, only 1 unpaired electron, but undergoing the para, which means that is not a high spin, that belongs to low spin. Clear? Then when a compound CH3 CCH3 with CHOH. CH3 is heated with the concentrated sulfuric acid. The major product formed is. So concentrated sulfuric acid, that will be elimination, that we know. The products are also eliminated product. So what that will do, OH will remove from the compound, which will lead to the formation of carbocation over here. That's not stable, we know that. So one of the methyl group will get shift to this part so that the compound will be formed. The positive charge over here, and then another methyl group were joined over here. Now, if I am doing the elimination, here I have CH3, CH3, CH, CH3, CH3. If I am doing the elimination on this carbon or this carbon, it will lead to less substituted alkene, right? That is not a major product. So the elimination have to happen on this hydrogen so that it can form a more substituted alkene. So which makes option A is your answer. Clear? A non-volatile solute X associates to form a dimer in benzene. 1.0 gram of solute is dissolved in 100 grams of benzene, producing a boiling point of elevation that is 0.256 Kelvin. The boiling point constant of benzene is given. Assuming complete dimerization, the molar mass of the solute is. So complete dimerization they mentioned. So it is forming dimer. So I is equal to 1/2, right? So delta TB is equal to I KBM. We are talking about the boiling point. So delta TB, they are asking molar mass of the solute. So substitute the other values. Boiling point elevation. Elevation is 0.256 I. That is 1/2. KB value is given as 2.56 into M. In M also we have 1 gram of the solute, 100 gram of the benzene as a solvent. So for number of moles, 1 by molecular mass I don't know, divided by 100 grams. So I want it in kilogram, so which makes it 0.1. Right. So upon solving this, what will I end up with? 0.256 and 2.56 will get cancelled very easily, remaining 1/2. So the molar mass will be equal to 50 gram per mole. For the reaction at equilibrium, calcium carbonate gives calcium oxide, carbon dioxide. H is greater than 0. If the temperature is increased at constant volume, which statement is correct? They are saying the temperature is increased at constant volume. So according to Le-Satelier principle, for an endothermic reaction, because H is in positive value, heat absorbs. So which is an endothermic reaction. So endothermic reaction, temperature is increased, so which will lead to more products. Correct? More temperature we are giving so that it can absorb to form the product. Simple. So if the temperature increases, what will happen? The Kp value will increases with temperature. Correct? So what about the pressure? So the pressure increases or decreases. They mentioned that that is maintaining a constant volume. So constant volume means more CO2 has been produced now because of the reaction is going to forward. More moles of gas in a fixed volume, which means pressure increases, right? So the pressure will increase. The equilibrium shifts to right. Pressure increases, equilibrium shifts to right. So Kp increases. That is the only answer we have. Among the following, the oxide that can act as both oxidizing and reducing agent. So if that want to act as in both means that should be in an oxidation state of varying to reduce or increase. Right? Let's say I have Mn, manganese. It can go +7 also, +2 also. If I'm having +4, that can undergo both. So that kind of scenario. So let's see here, NO2, where the nitrogen oxidation state is +4, it can be oxidized to NH3, where the oxidation state becomes +5, and it can be reduced to +2 +2 or 0 or -3 as well. So it can act as an oxidizing agent. What about SO2? So SO2, which is now here, that is +4 oxidation state, which can again go +6 oxidation state also, or 0, correct? So that can also undergo both the thing. And CO2, that is in maximum oxidation state of +4 only, it can't go beyond that. What about N2O5 nitrogen? That is in maximum oxidation state of +4, +5. So which means A and B, that is in the option, that makes it correct. The equivalent conductance of NaCl, HCl and CH3COONa at infinite dilution of 126, 426, 91 respectively, the equivalent conductance of acetic acid at infinite dilution is. So how we can solve it? We know that of NaCl will give you Na plus Cl minus, that is 126.5, and for HCl, that is H plus and Cl minus, that becomes 426.5. Similarly for sodium acetate, which is acetate and Na plus, so that is 91. I want acetic acid, so H plus and acetate I want. So how can I do the calculation? Acetic acid equal to HCl plus CH3COONa minus NaCl. So what will happen? The sodium and this sodium will get cancelled out, and this Cl and another Cl will get cancelled out. Remaining, what do I have? The hydrogen and acetate. Correct? So that I will get an answer. So to work on it, this is a formula. Just put the answer in the format. In the Hofmann bromide degradation, when benzamide is treated with Br2 in aqueous NaOH, the mechanism involves the formation of intermediate X, which then undergoes the rearrangement. The intermediate X is, before rearrangement, I want an intermediate X. Right? So if you know, if you followed our channel, you must be knowing this Hofmann bromide degradation method. Mechanism goes RC double bond O NH2, right? With Br2, first it will take up one hydrogen and Br occupies that position. Then OH minus will come and take up the hydrogen. So that will be forming C double bond O N Br, right? So now, once the hydrogen is leaving the compound, that will form a double bond over here, so which will form RC double bond O N Br. Br will leave the compound and the rearrangement happens over here. So which will lead to the formation of Rn C. The base will attack the carbon again, and the hydrogen will be attacking over here, so that it will form RNH, C double bond O, OH. Then OH will come again to take up the hydrogen. What they are asking is, before the rearrangement, what is the intermediate X formed? So the intermediate X over here RCONBr. RCONBr, which is option B, is your answer. You may ask, ma'am, isocyanate will also form, but after the rearrangement only it forms, right? So which makes B is your answer. Arrange the following in increasing order of acidity. So first one, ethanol, propanoic acid, and chloro-substituted acetic acid, fluoro-substituted acetic acid. Very simple question. Alcohol must be the weakest, so one must be in the top. So A or C is your answer. Then must be an Cl or fluoride, because that is an electron withdrawing group, so that it will increase the acidity. So Cl or F, which is withdrawing more? F will withdraw the more electronegative. So which makes, again we are getting A or C. After fluorine, there must be 3. So which makes option A is your answer. The aqueous solution, the correct order of basicity is, this we have solved already and asked so many times also. I know very well you can answer to this question. You are following our channel. Aqueous solution in case of methyl substituted. So what is the order? The order follows. We have to consider steric, we have to consider inductive effect, and also the solubility. So which follows starting from the secondary? There is only one answer given. That is A, and then comes where we have primary and then tertiary. Total number of stereoisomers possible for 3 bromo, 2 chloro, 4 methyl hexane. This is hexane 1, 2, 3, 4, 5, 6, 3 bromo, 2 chloro, 4 methyl hexane. So total number of stereoisomers here we have. So this position, this is chiral, correct? This is also chiral. What about this? This is also chiral. So the chiral centers are 3. So which makes 2 to the power n. That is, whenever you are doing this type of question, check for meso compounds also. If meso is there, due to internal compensation, that won't be an optical isomer, right? So there are totally 8 isomers possible. At 500 Kelvin, the equilibrium constant Kp for the reaction. If the reaction is started with 2 moles of SO2 and 1 mole of O2 in a 1 liter container, at equilibrium, 90% conversion of SO2 occurs. The equilibrium pressure is approximately. This question may be look complicated, but very simple question if you understood the logic. So what they have said is 2 SO2 plus O2 gives 2 SO3, right? So initially that was 2 moles of SO2 and 1 mole of O2, that is in the same ratio, so which is producing 0, and at equilibrium 90% conversion, 90% of 2, that is 1.8, right? So remaining I will be having 0.2, and 90% of this one is after conversion, sorry, 1 minus 0.9, that is 0.1. Now how much must have been formed? That is 1.8. So total moles here I have, that is equal to 0.1 plus 0.2 plus 1.8, that is 2.1 mole. What they are asking, the equilibrium pressure is approximately. We know PV is equal to nRT. So P is equal to nRT by V. N is 2.1 into R value 0.082. T value, that is 500 Kelvin, divided by volume, that is 1 liter container. So which will give you 86.1. So the nearest integer would be 86. In the reaction, MnO4 minus plus oxalate plus H plus, Mn2 plus is formed with carbon dioxide in acidic medium. When 1.58 grams of KMnO4 reacts completely with oxalate, the volume of CO2 produced at STP. Balance this equation. So the balanced form would be 2MnO4 minus plus 5C2O4 2 minus plus 16H plus gives 2Mn2 plus 10 CO2 plus 8 H2O. Right. So from the balanced equation, what you will come to know, KMnO4, 2MnO4 forms Mn2 plus, okay, carbon dioxide produced from, which is in 5:10. That is 1:2 ratio. Now, calculate the moles of KMnO4. They have given 1.58 grams out of, not out of, molecular mass is 158. So the moles of KMnO4, that is 1.58 by 158, that's equal to 0.01 moles. So 2 mole of MnO4 minus produces 10 mole of CO2. 0.01 MnO4 minus produces, so 2 mole produces 10, so 0.01 produces what, which is 0.01 into 10 divided by 2, correct? So which will be 0.05 moles of CO2. They are asking it in volume. So this much moles, convert that to volume. So 0.05 into 22.4 liters will give you, in 11. In ml they are asking, so which will be 1120 ml. It is prepared by dissolving 3 grams of mixture of NaCl 50% by mass, glucose is 50% by mass, in 500 grams of water. The depression and freezing point, K into 10 to the power minus plus 2, we have to find. They have given 50% by mass, which means in 3 grams NaCl is 1.5, right? 50%. Again, glucose is also 1.5 grams. So let's find out the number of moles of NaCl and glucose. First NaCl, that is 1.5 divided by 58.5, and which will comes out to be 0.025. Similarly for glucose, that is 1.5 divided by 180, that is 0.008. Okay, as a next step what we have to do, we have to find the molality. Before that, remember, glucose will not dissociate, so the I factor will be 1. But what about NaCl? NaCl will form Na plus and Cl minus ion, so I will be 2. So in that case, the effective moles, the effective number of moles will be, NaCl will get dimer, not dimer, it will be dissociate into 2. plus glucose will not dissociate 008, which will be 0.059. Okay, now let's substitute in the formula. That is, this part is important in this question. Okay, the previous part. So delta TF is equal to, I value we already substituted, KF into M. Now we have to find the number of molality, which is 0.059 divided by 500 grams. So that is 0.5, which will comes out to be 0.119. Let's substitute the values given. KF value is 1.86 into 0.119, that is equal to 0.221. They are asking 10 to the power 2, which will be 22.1 into 10 to the power 2. Approximately the answer is 22 here. Next question, in the compound Na4FeCN5NOS. If you know what this compound is, let me know in the comments. If the oxidation state of Fe is X and oxidation state of N in NOS ligand is Y, then X minus Y what it is with the modulus. Okay, so let's see what is this complex is. FeCN5 times NOS. What is the charge? I have Na4, which is 4 minus over here. Then that will get compensated, right? Now let's find out the charge of iron. Yes, plus 5 into cyanide, that is minus 1, correct? What about NOS? NOS is again minus 1. So 1 into minus 1, which is equal to minus 4. So totally X minus 5 minus 1 minus 6. So X becomes plus 2. What about Y? Y is nitrogen oxidation state, it's NON. So NOS is basically formed from NO plus and sulfide. Okay, so I'm just substituting the values over here. X, oxygen is minus 2, oxide. Sulfide, that is 2 minus, that is equal to minus 1. Here we took minus 1 only, right? So totally it will be plus 3 oxidation state. Nitrogen will be in plus 3 oxidation state. So X to Y, that is 3. With the modulus, the answer becomes 1 to this question. Practice more and more questions. Let me know if you have any doubts. Thank you.